Over the past decade, Turkey has emerged as a rising power in the global defense industry. One of its most notable achievements is the country's successful production of a 50,000-pound cruise missile at a modern defense industrial facility, fully supported by domestic technology. The production of this heavy cruise missile is not only a symbol of military but also a testament to Turkey's technological advancement. Production of the cruise missile begins with the digital design phase. Turkish engineers use advanced simulation software to design the aerodynamic structure, propulsion system, and the integration of the warhead and navigation system. Through computer simulations, various flight scenarios are virtually tested, including low-flying trajectories and radar-evading maneuvers. The missile body is constructed from a combination of special metal alloys and lightweight composite materials. The goal is to achieve a balance between structural strength and weight reduction. The main structure is formed using CNC machining, and anti-corrosion and anti-radar coatings are applied. The missile body modules are assembled in stages. This 3,000-pound cruise missile uses a turbojet engine. Engine production is carried out in a separate facility with extremely high precision. As this component is the heart of the system, the engine is tested under various conditions to ensure fuel efficiency, thrust stability, and long-term endurance. High-yield warheads are manufactured separately, using high-energy explosives. This process follows strict safety procedures and multiple testing stages. Warhead types can be customized, ranging from bunker, penetrator, high-yield fragmentation, precision warhead for strategic targets, quality testing and certification, before being declared operationally ready. Each missile undergoes a comprehensive series of tests, including vibration and shock tests, extreme temperature tests, and electronic system compatibility tests. This missile is produced in high-tech defense factories owned by national companies such as Roketsan and other industrial partners. These facilities are built to international safety and quality standards, equipped with automated and semi-automated production lines, high-precision CNC machines, specialized composite and metal materials laboratories, extreme environmental testing chambers, and an integrated digital quality control system. The entire production process is strictly monitored to ensure every component meets technical specifications and military standards. The Turkish government aims to fully master strategic weapons technology, including high-precision, long-range missiles. The 3,000-pound cruise missile is designed to carry a large warhead, with a range of hundreds of kilometers, capable of striking high-value strategic targets such as command centers, military facilities, and critical enemy infrastructure. One of the main advantages of Turkish cruise missiles is their navigation system. This missile combines an inertial navigation system, military GPS, terrain contour matching, and a terminal phase image guidance system. The integration of these systems is carried out in a clean room with high standards to prevent electromagnetic interference and installation errors. The successful production of the 3,000 cruise missile has significant strategic implications for Turkey. The country now possesses long-range precision strike capabilities, enhancing its national deterrent. Furthermore, mastery of this technology opens up export opportunities to friendly countries in need of modern weapons systems. The production of the 3,000-pound cruise missile in a modern Turkish factory demonstrates a major transformation in the national defense industry. By relying on local design, precision manufacturing, and advanced control systems, Turkey has proven itself a world-class strategic weapons producer. This achievement not only strengthens national defense but also positions Turkey as a key player in the global military industry.